So in a switch up, our next speaker is Wanggi Lim from Caltech IPAC. Take it away.
All right, everyone. No, time to wake up. Don't fall asleep. Okay, all right. All right, hello everyone. I'm Wanggi Lim from Caltech IPAC. So I am a Roman person, but this science case is actually, I use it for the SPHEREx data because it is actually live out there. So the title is title was Synergizing SPHEREx and Roman for blah blah blah. But I'm actually selling SPHEREx a Galactic model for the other Roman science. That's actually what it is. So I know many of you already know about Roman, so I will just explain a little bit about the SPHEREx. So I will just try to read this in one breath, the full name of SPHEREx. The spectrophotometer for the history of the universe, epoch of the urea ionization, and ice explored. That's a SPHEREx. That's a long name. And then it is actually the spectral imaging survey. So it has 102 spectral channels. So you can actually naively think they have 102 bands in there, but they're really narrow. And then using the linear variable filters, you don't need to actually worry about it. And then angular resolution is about 6 arc seconds, which is a small telescope. And then the most important thing is the year 1 data release is scheduled in this November. So all sky map of all 102 channel image maps will be actually just released at that time. So we can actually utilize those data by the time. Oh, sorry. You can probably just go to this the QR codes and then find out more about this SPHEREx and also more about the mosaic tool from the URSA. Okay, so this is the SPHEREx data toward our the pilot study location, which is centered at the galactic latitude, longitude and latitude 300. So it is about a 2 degree by 2 degree location, and then you can actually see a lot of really the point sources, which is really big. Probably one point source is probably around the size of the detector of the Roman. But anyhow, we have those nice data, and then we used. we used some of those the background estimation the methodology. So by channel, so basically applied to all these 102 channels, just from the other 0.05 micron to the 5 micron. So we use so-called as large medium filter method, which is a size of the 14 arc minutes, which is about the size of the giant molecular clouds at about 5 or 6 kiloparsec distance from here. So we just try to block it and then make the other medium filter. And then put those medium values in the center, so that we just move those medium filter and then make these models, the background models. So it is relatively robust against the other bright sources, and then recover diffuse galactic emissions, and there are many the benefits. But the biggest benefit is we will actually provide these galactic plane models for your galactic sciences. So whenever you need, you just you can just tell me, and I will just provide that for all these 102 channel maps, from the 0.75 micron to the 5 micron. So you can use it. Okay, so and then we have a plan to actually put entire galactic plane galactic model at some point after the year 1 data release. We means not just SPHEREx the team. We mean just my individual the collaboration team. So it's not real a SPHEREx a core science or something. Just to be clear. All right, so this is the galactic model based on this observation. So you just remove all these point sources and then just retrieve all these the emissions, the diffuse emissions, and then with the other medium filter, and then you can approximately basically calculate these the background around these locations. So you can actually see this. See here, so if you see really in detail, you can probably recognize those structures are actually residing here, right? So yeah, so this is example from the 4.62 micron, but we basically did it for the other entire 102 channels. Okay, so like this is the examples for the other 9 channels that we basically did, like which is from this 3 micron to the other 5 micron. So using this one, like why do you need to actually care about that? Like why? So where do you use these background models? But like from Roberta's talk, you already heard about it. Like we need to actually know the background to get the other extinction, because like in order to know about how the light has been extinguished, you need to actually know about the background. If you do not know the background, you do not calculate the extinction. Okay, so. For this one, the benefit of this method is you don't actually need any background stars. You can simply just use the background models per channel, so you can just simply apply that. The downside is like it's not like as accurate as the stellar models, right? Like and then angular size is like really big, and then it is about all these the diffuse emission. So there are actually pros and cons to use the stellar background and then like the galactic background. But like with the galactic background, you can actually go further, like a longer wavelengths, because the stellar models are having the flux density basically drops after the other about like 2 or 3 micron. So you have a really difficult time to calculate the extinction like in this like a longer wavelengths. But like with diffuse ISM with the dust emission, you can actually do it. So that's actually one benefit. There are pros and cons. And then obviously you can actually check the other large scale the Galactic ISM studies with those, so you can apply that. So then, so there are some like examples of like how you can actually use for these extinction maps like from each channel. So by normalize that to the other 1 wavelengths, you can basically get this like the normalized kappa curve. So you can estimate the extinction law of or in this like wavelength regime. Okay, so that's the benefit. So this is only for so in the center there's only there are the extinction the normalized extinction curves from the SPHEREx data only. But like you can also as shown in the right, like you can actually compare them to these some of those like dust models. And then, this on the left, this panel basically shows that like where we actually got this like the example data from this like dark regions. It's not really super dark from the other locations, but it is actually dark. Trust me, it is actually one of the IRD series, infrared dark cloud regions, like in the catalog. Okay, so so we got these examples of like how to use your SPHEREx data like to get this like extinction law. So this is like a little more example how you can actually combine them with the other even longer wavelengths data, like from the Spitzer-Wise and also Herschel, and then you can basically compare them to the more complex the dust models. Now, for example, here in the 12 micron Wise data, it is actually showing that like the observed data probably not really following these like the ice mantle models for this specific location. But like don't trust this like 100% because this like background of this location is not like a really accurate. Like I didn't calculate in that way, but like it is actually trustworthy. So you do not actually expect a super thick ice mantle on those locations. That's what you can actually get. All right, so then like what is the benefit for the Raman of this like a SPHEREx based like background? So first of all, so I will just say these extinction laws, like estimated from this SPHEREx in the larger scales, you can actually apply to the other Raman. So you can actually estimate like those extinction effect of your Raman locations. Okay, that's actually one benefit you can actually get. And then obviously you can actually flag any of those potentially problematic locations for your either like the photometry or imaging or other analysis like from the Raman. And then secondly, like for the completeness, yes, like you can actually see approximately what kind of this region is, like from this like galactic background emission from all these different like 100 channels. So you can actually get the SEDs and also like some of those estimation about like if it is actually just like a PDR region, and H2 regions, and then what is the approximate of the other YSL fractions and things, you can actually get it. And then for your quality assurance, like you can also use this like a SPHEREx data, like to SPHEREx the models, the Galactic models, to get like your flags for your Roman data. Okay, so yeah, this is just like showing again like where you need to actually get like a more flag. So if you just want to do like some like a detailed photometry, and then if you just go to these kind of locations, and then you just look into this the Galactic plane, like the background models, and then see, okay, so we may actually put like a low weighting like values over here, because like these locations are having like a high contamination by the background. So something like you can basically use them for the other larger scale survey type of the other your science. Okay, like for the like the almost like the semi-automatic way. But if you want to like go in real detail, you basically need like a better and more careful methodology. But like we can actually discuss that more later. Okay, this is basically the last point. So you can actually have it is almost like the same thing, but like this a little more detailed. You can get the other SEDs, and then like in each channel, you can basically like estimate some like residuals like of those the wavelengths. So like because the SPHEREx channels are having like divided in like 102 within like this like a 0.75 micron to 5 micron, you can actually combine them to make this like a synthetic the filter function of the either like either like a Spitzer or like either Wise or like or for the Roman. There might be some difference, but like that's something you need to figure out. And then there are lots of the potential of this like simple galactic like diffuse background model can be applied to this the Roman sciences, because it is like a much like a coarse but like a much larger scale of the survey, and then you can actually apply that like very easily to your science. Okay, so that's it. So like again, I was actually trying to sell these like background SPHEREx based like background models for the Roman science, especially for the galactic plane survey sciences. So we can actually making some synergies in between these two surveys. And then I like this the topic of this conference is like shifting landscape, and then these two surveys, the facilities, and also like all other facilities like Euclid and LSST, we are really shifting our landscape from this like individual source observations to this like a large, fast, efficient the type of the other surveys, right? Like this is one thing you can easily apply, and then you can actually just play with. Okay, all right, I'll stop here. Thank you.
All right, thank you, Wanggi. Any questions?
Thank you. This looks great. So you were focusing mainly on the kind of galactic plane and galactic center. Is there, how far away from the galactic plane do you expect this to work?
Thank you for asking that question. So it's not like completely decided yet. Like our first pilot study paper is just submitted this morning, actually. So we are actually thinking about how far we will actually extend that. Obviously, we will cover all the fields in the other Roman galactic plane survey. So maybe approximate to like a plus minus 10, and then like of the other latitude, and then longitude maybe plus minus 80, like to cover everything. And then we will also like do some researches on the some locations that like a Roman galactic plane survey does not actually cover yet, something like Orion, like the star-forming regions. Or we can also test like some other like isolated locations. It's very easy. It is just like a medium filter method. So you can just like put this medium filter and then move it, and then you will get this like the background estimation. That can be also foreground for the external galaxy the sciences. So it is like a lot of potential to actually apply.
Time for one more quick question. Very quickly, so with increased data from SPHEREx, right, I'm really happy to see this type of overlap. Do you expect resolution, data quality? I mean, SPHEREx obviously long-term mission. What's the improvement to be seen there?
Yeah, that's actually one of the downsides of this thing. So currently, in our quick calculation, with quick release 2, the QR2 of the SPHEREx, we could actually go down to a depth of about a 14 to 15 meg of depth, but that is actually for one channel. So if you just combine those channels, you can actually go deeper. So I would say maybe you can actually get down to the other 17-ish. But with the data 1 release, it will get a little deeper, and then by end of the survey of the SPHEREx, you will have a little better depth, yeah, sensitivity. So yeah, it's not Roman level, but it is getting better. So.
Exactly. Right. Okay, let's thank Wanggi one more time, please.